In this lab, we're going to learn to predict the final temperature of a mixture of two different volumes of water at two different temperatures. So let's suppose you had an amount of hot water. And let's say you had an amount of cold water. And you can decide if you want to have more hot or more cold. Let's say you had the same amount to start with, just to make it easy. If you had the same amount and you mix these same volume, different temperatures, and you mix these two together, all you'd have to do is take the average of these two temperatures, and of course the average would be what you'd have at the end. But let's suppose you had a different amount. Okay, perhaps you had more of the hot water. And now you want to realize, well, what's the final temperature going to be? Well, remember, we always try to take a drawing for each one of our heating curves. Now this is water, so we're starting off at zone 3 for liquid and a high temperature, and we're actually mixing it with another sample of water, so it's going to be the same heating curve, but now we're starting at a lower temperature for this one, and then when we put them together, they're going to meet somewhere in between the hot and the cold. That's going to be the final temperature. So if you use the math for this, this is going to be the zone 3. So it's MC delta T. That's going to equal the MC delta T of the cold. Now you know that the C value for this zone is 4.18 joules per grand degree Celsius. And that's going to be the same thing on this side, 4.18 joules per grand degree Celsius. So you literally could just divide out these from both sides because it's just an algebraic equation with the same number on both sides. And then you want to get the delta T of each one. So the delta T over here is the hot. This is delta T. So you're going to know that one. You're going to know the delta T of the cold. You're going to know that one. And then, of course, you know the mass of the cold and the mass of the hot. So you could do this lab first and just see how it comes out. But what you want to be able to do is you want to be able to predict the final temperature. How would you calculate that final temperature? So what you realize is that the final temperature of the hot is going to be colder than the initial. So that's going to be the first temperature minus the final. Has to be the final one over here because it's lower than the original temperature. Okay, so this is the final right there. Whereas over here, see, the final temperature is higher than the initial. So you're going to take TF minus first temperature. And then, of course, you need the mass of each one. So the goal of this lab is, can you predict the final temperature mathematically and then see how well you do with it? Okay? So you could obviously, after the fact, calculate what the final temperature should have been and then see how it compares with your results. Now we're going to move on to the next lab. In this lab, we want to discover if it's better to cool your hot chocolate by adding the milk first and then waiting 5 minutes, or waiting 5 minutes and then adding the milk. Instead of using this with actual hot chocolate and milk, what we'll do is we'll simulate it with water. So what you need to do is you need to figure out, how am I going to test this out? And I'll just give you the quick version of the picture, but this is something you should really be able to figure out yourself. So here's your hot chocolate, which is really just hot water for now. Okay? In an experiment, of course, you only want to have one variable. So you're going to need to have the same amount of hot water in each of these. They have to start off at the same temperature. You're going to have the same amount of cold water, which simulates the milk. And it has to be also at the same initial temperature. And then you can figure out what you have to do and when you have to do it. And then you want to make sure that you compare which one ends up the cooler out of the two. So this one, you're going to add milk first, which of course is your cold water. and then here, and then wait 5 minutes. Whereas this one, you're going to wait 5 minutes and then add the milk second. And think about it. Try to make a guess as to which one's going to work better, and then try it out in the lab.